Welcome to the lesson on descriptive analysis. Upon completion of this lesson, learners will be able to discuss descriptive analysis and its various components. Learners will also be able to calculate the descriptive statistics of a population. Data and statistics drive every aspect of quality control. Graphical representation is great for visualizing where the data lies, but statistics are needed to help fully understand the data and its analysis. Descriptive analysis is a foundational statistical method that focuses on summarizing and describing key features of a dataset through two main components. Measures of central tendency like mean, median, and mode identify the center point or typical value in a dataset, providing insight into the average or most common characteristics of the collected data. Measures of dispersion like range, variance, and standard deviation quantify how spread out or variable the data points are from the central measures, indicating the consistency or variability within the dataset. Now, let us look into statistics and descriptive statistics. Statistics is the branch of mathematics dealing with the collection, analysis, interpretation, and presentation of masses of numerical data. In other words, statistics aid in determining how many samples are to be collected, the appropriate tools needed to analyze the data, and how the analysis should be interpreted. It also provides tools that aid in the graphical representation of the data. Once these steps are followed using statistics, the results will yield important information about the material being analyzed, and an informed decision can be made. Descriptive statistics, as their name suggests, is the analysis of data that describes or summarizes a population or sample and helps us determine patterns from the data. One cannot make decisions based on descriptive statistics alone. Examples of descriptive statistics include mean, mode, median, standard deviations, and variance. It is important to note that a statistic describes a sample taken from the population, while a parameter describes a population, and statistics and parameters are not always equal. The mean, or average, of a sample is obtained by adding the values of the sample and dividing by the number of samples. It can be best described using the following equation. Let's take a look at the sample data in the table to find the mean of the first subgroup. There are 5 data points in the sample. Therefore, the addition of the values of subgroup 1 is divided by 5, as shown. The mean of subgroup 1 is 101.4. Similarly, the mean of subgroup 2 is the sum of all values divided by 5, which is 103.2. The median is another descriptive statistic that is used to determine the value that is the middle of all other values. To find the median, the sample data is ordered from lowest to highest value. The median will have equal values to the left and to the right of it. If the sample size happens to be even, then the median can be obtained by adding the two middle values and dividing them by 2. Let's revisit the data in the table to obtain the median. First, the data is placed from lowest to highest value as shown below. With 15 data points available, the median is identified as the 8th value, which is 102, in the ordered dataset. The median value of 102 is positioned such that there are 7 numbers on either side of it. The mode is the most frequently occurring value in a sample. To determine the mode, it is again beneficial to arrange the data in ascending order. Using the data from the table, as seen below, the number occurring with the highest frequency is also 102. The mean, median, and mode of a sample describe measures of central tendency, or where data tends to be gathered. The relationship of these measures can reveal quite a bit about the distribution of the data. For example, if the mean, median, and mode are close to each other, the distribution of the data is said to be symmetrical, like the curve on the left. If the mean is higher than the median and the median is higher than the mode, the distribution of the data is said to be skewed right, like the curve in the middle. If the mean is lower than the median and the median is lower than the mode, the distribution of the data is said to be skewed left, like the curve on the right of the slide. The next set of descriptive measures, range, variance, and standard deviation, measure dispersion. Measures of dispersion describe where the values fall with respect to one another and to the mean. If data has a large dispersion, then the graph of that data would be short and wide, with a large variety of values. If data has a small dispersion, then the graph of that data would be tall and skinny, with only a small number of values seen in the data. We will discuss more about range and standard deviation in the upcoming slides. The range, R, of a data is obtained by subtracting the minimum recorded data point from the largest recorded data point. For the sample data shown in the table, the maximum data point is 104 and the minimum data point is 99. Therefore, the range is 104 minus 99, which is 5. Variance is a statistical measure that quantifies how spread out a data set is from its mean value, calculated by finding the average of squared deviations from the mean. Using our data set from the table, we first calculate the mean by summing all values and dividing by the total number of values, giving us 102.07. Then, for each value in our data set, we subtract this mean and square the difference. For example, for 99, we calculate 99 minus 102.067 squared, which equals 9.4, and for 104, we calculate 102.067 squared, which equals 3.74, continuing this process for all values. Finally, we sum all these squared differences and divide by the total number of values, resulting in a variance of 1.80. This relatively low variance indicates that our measurements are fairly consistent across all three columns, with minimal spread from the mean value. Note that the variance is expressed in squared units of the original measurements, which is why standard deviation or the square root of variance is often preferred for practical interpretations. The standard deviation of a data set describes the spread of the data within the distribution. Because of how it is calculated, the standard deviation shows how each individual value falls in relation to the mean of the data. The standard deviation helps us identify the dispersion of the data. In a normal distribution, the standard deviation tells us that along the mean, about 68% of the data will lie within one standard deviation of the mean. About 95% of the data will lie within 2 standard deviations of the mean. And 99.7% of the data will lie within 3 standard deviations of the mean. This is referred to as the 68-95-99.7 rule and is illustrated here. Here is an example of how descriptive analysis would be applied in manufacturing quality control of a drive motor shaft dimension. The mean diameter measurement tells us the average size of all manufactured shafts, which must precisely match engineering specifications for proper motor function and power transmission. The standard deviation reveals how consistently the manufacturing process produces shafts within tolerance. Even small variations could lead to increased vibration, reduced efficiency, or premature wear. The range helps identify potential manufacturing issues by showing the full spread between the largest and smallest shaft diameters produced. Too wide a range might indicate machine tool wear or calibration problems. The mode shows which specific diameter measurement occurs most frequently, helping verify if the production process is consistently hitting the target specification. The median shaft diameter, being the middle value when measurements are ordered, helps identify if there's any skew in the manufacturing process that might be causing diameters to trend larger or smaller than intended. In summary, descriptive statistics help us to define the distribution of a sample population. Measures of central tendency serve to identify where the data is concentrated, effectively pinpointing the typical or central values in the data set. Meanwhile, measures of dispersion reveal the relationships between data points by quantifying how they vary from one another, showing whether the measurements are tightly clustered or widely scattered across the range. Together, these statistical measures provide a complete picture of both the typical values and the variability within a data set. Using these statistical tools, you will now be able to graphically analyze whether a product is meeting quality standards. Thank you.